Hello students. Welcome to the channel. Welcome again once more. This is also the other video about a little bit of a nomenclature. So just gonna be treating some of the questions that are related to it. So without wasting a lot of time, don't forget to like, share, comment, and subscribe, and then tell a lot of people about this channel, and let's grow as a family. Okay, right, so without wasting a lot of time, let's just get into the video and try to treat these questions. All right, so this is a past paper, a grade 12 past paper, September, Free State 2023. So let's try to do this thing. Okay, so the first thing that we need to do is just like read the statement. Okay, so the letter, this is question 2 by the way, so it says the letter A to E in the table below represents the 6 organic compounds. All right, so we have butane, we have those compounds that they've given us, so, and then let's go to the first question. The first question, it says write down the letters representing a compound with the general formula CnH2n minus 2. All right, so we know that CnH2 minus 2, it's a general formula for a what? Can you guess? Yeah, it's a general formula for alkyne. All right, so the first answer for us is going to be the first question is going to be, the first answer is going to be alkyne. Let's go, alkyne. It's going to be alkyne. But remember that here, they do not need you to write the words. What do they want? They say, write the letters. Write the letters. I was writing just for you to understand. Okay, that says write the letters. Which one represents an alkyne over there? Because they say write the letters representing a compound with the general formula of this one. So you go up and you check. You see this one? This is a what? Butane, which falls under what? Alkane. You out. And then this one, you see, you check. You can even draw this one just for you to understand. All right, so let's try to actually draw it so that we can understand. So we see we have C, H, H. I'm not sure if you guys can see this. CH, and then we have another one, CH. I'm just gonna leave this line just like I've drawn the H. And then we have the other one, which is a C. The other one is also a C. The other one is also a C, like this. All right, but remember that always carbon has to have 4 bonds. It has to have 4 bonds, and then oxygen has to have 2 bonds. And then hydrogen has to have 1 bond. But when you look here, you see that you have 4 bonds. But this one only has what? 2 bonds, which I can put the what? The other bond over here. Now, how many bonds does it have? 1, 2, 3. It's not completed. Then you have to put the other what? The other bond over here. Now, it makes sense. 1, 2, 3, 4. Now that makes sense. So when you look at this, what's this compound? This compound is an alkyne, which I can put this as what? As my answer, because now we were looking for what? For alkyne. All right, so I'm just going to put the answer as what? As B, because what did they want? They needed the letter, right? So don't forget that, because a lot of students do forget this thing. So right, so we go to the second question. They say write down the letter representing a ketone. A ketone. Right. So how can we know that something is a ketone? Well, a ketone has something like this. It's sort of like a general formula, you know. This is a ketone, right? So how can I see which one, or maybe kind of looks like this one over here? Check this one. It's an alkane. This one is an alkane. This one is an alkyne. This one is just like a it's not an alkane. It's not the alkene. It's not the. It doesn't have what we are looking for. It doesn't have double bond, by the way. So we're just gonna skip it. Let's go to this one. This one, it looks the same as it kind of looks the same as what we did here, because it has this thing. So we're just gonna put this thing as our answer, because now we have this. All right. So which means our answer. Why, guys? I hope you guys can see. All right. So our answer is going to be what's this? It's a D. All right. So that's our D. Maybe let's just write. Let's put a rough sketch over here. Let's just write it over here. Okay. Let's just write it over here. The answer would be what? The first answer was B. It was B. And then the other one, the ketone, was what? Was a D. The ketone was a D. Alright, so I hope that makes sense. Alright, so a compound that can be used as a fuel. Which compound can be used as a fuel? This one, it's kind of like a little bit tricky, and it comes a lot more times in in metric examination. It kind of, it comes a lot of times. So how can I know that something can be used as a fuel? So for something to be used as a fuel, it has to have a carbon and a hydrogen atoms only. Why? Is because they can combust, releasing a large amount of what? Energy to form a heat. So it does not have to be a carbon and a hydrogen and other thing. It only has to be carbon and what? And hydrogen. Does that make sense? Hope it makes a lot of sense. All right. So which means that would actually be it would actually be, when we look here, we see a butane. Butane is what? Butane has only carbon and hydrogen atoms only. This one only has carbon and hydrogen atoms only. But this one has Cl. This one is O. This one only also has what? O. So which means we cannot take this one. So, which means I can take what? An A and a B. So I'm going to take A, because they need the letters. You're going to put this one. All right. So you don't have to write those names. All right. So they continue to say an unsaturated hydrocarbon. What's an unsaturated hydrocarbon? They need a what? An saturated hydrocarbon. Let's break this down. So an unsaturated hydrocarbon. How can we know that something is unsaturated? So for something to be unsaturated, it means it has to have a double, or maybe like more than two, or maybe more than one bonds. And at the same time, because they said it is a hydrocarbon, it also has to have a carbon and also a hydrogen. So let's see which one does have more than one bonds. We look. This one, it has one bond. This one is alkane. It has one bond. This one has more than one bonds, but it is not a hydrocarbon. So we just gonna skip this one. Let's go up. This one has carbon and hydrogen atoms only, and it also has what? More than one bonds, right? So which means this one is the answer. Let's check the other one. Let's see. This one has double bonds, more than one bonds, but it has an oxygen, which means it does not qualify. So which means I'll put the what? A B, which is my answer. You see? That's my answer. Hope that makes a lot of sense. All right, so let me just pull this one a little bit. All right, so I hope you guys can see this thing, right? So they continue again and they say, for compound E, write the functional group. Write the what? The functional group. What is the functional group for compound E? And what actually it is a compound E? Compound E is a what? It's a compound E is carboxylic acid. You see, it's a carboxylic acid. Let's just put a rough sketch over here. Carboxylic acid. It's just a rough sketch, guys. Carboxylic acid. It's a carboxylic. Guys, we're not teaching not teaching language. Carboxylic acid. All right. Okay. Carboxylic acid. So, by the way, what's a functional group for it? It is COOH. This. So, what's this thing in words? Name. Remember they said what? Look at this one over here. Name. They didn't say write the structural formula or something. They said name. Remember, you in this topic, it's easy to make a mistake and it's easy to what? To get something right. So you have to listen to the statement. It kind of like treats if you understand or you are not always in rush. You have to always be just be gentle, right? When you're writing this thing is very easy, but it needs you to understand it and read it. Don't just undermine this topic, right? So okay, let me stop yapping. Right. Okay, so what's the functional group for compound E? Compound E is a carboxylic acid. All right, so what's that? So how can I know that this is, or maybe how can I name this thing? This thing has what? It is, let me say, it is negative C, not negative Y. This is a bond, by the way. It is this one. All right, so this thing is carbonyl and hydroxyl, if you notice this one. So carbonyl and a hydroxyl, when you combine them, they're gonna form what we call a what? Carboxyl. Right, so which means our answer here would be carboxyl. That's because they said what? Name. Remember that. All right, so let's go a little bit down. All right, so they say structural formula of this functional isomer. They need the what? The structural formula of this functional isomer. Hope you guys know what's a functional isomer, by the way. So a structural formula for its functional isomer is like another compound that has the same molecular formula but with different what? Functional groups. What is that? Which one is that? Let's see. Because now we have of what? Of compound E. What's a compound E? Compound E is butane. Is butanoic acid. Alright, so it's 1, 2, 3, 4. Not sure you guys like, yeah, not sure if you guys can see. It's like how I'm gonna put this thing as like this, and then we're gonna put, because it's a carboxylic acid, just gonna put these lines like this as if they're H's, guys. But don't be like me, guys. Don't be like me. These are like represents the H's, guys. You know, they kind of represent the H's. I'm just like, you know, I'm just writing this thing just for you, just for me to be quick. But just assume that here they are H's. So right. So, and then they say the functional group. I mean the functional isomer for this one, which means it has to have what? The same molecular formula, which because they said what? Isomer, and then but they have to have what? Different what? Functional groups. All right, so this one has this functional group. So how can I change this? What's the functional isomer for a carboxylic acid? It's a what? Functional isomer for carboxylic acid is it's an ester. All right, it's an ester, and for ketone, it's a what? This is how you can claim it. For ketone, it's what? It's an aldehyde. So that's how you can claim it. Just claim it like this way. So for carboxylic acid is going to be ester. So let's draw the structure, because they said what? The structure. Remember that they said what? That's why I said you have to listen to the statement. They said they need what? Structural formula. So the structural formula, you can put it in this way. 1, and then we put the other one, H, over here. We say this one at the top. Let me just write the H's. Now some of you just get confused a bit more easier. So I want to put this thing so that you guys can understand what I'm trying to put out. You can put this thing at the top. It's connected to this one. So you can put this one in this way. This one, and this one, and this one, and this one. Okay, so that's how you can do that. All right, so this is your what? This is your structural formula for your functional isomer. Because you see, if you want to check, you see it has two oxygens. It is 1, 2, 3. Guys, this one is not the, it's not the H, because I said it has to have what? 4 hydrogens. Now this one has what? 1, 2, 3, 4. Now it's okay. It's gonna be 1, 2, 3, 4, 5, 6, 7, 8. Right? Remember I said this one, you just assume that they are H's, because I was lazy to just write those H's. So let's see if this one also has the 8 H's. If it doesn't, which means we've made a mistake. 1, 2, 3, 4, 5, 6, 7, 8. You see? So which means is okay. How many oxygens? 1, 2. 1, 2, and then 1, 2. See? How many carbons? 1, 2, 3, 4. 1, 2, 3, 4. Which makes a lot of sense. It's pretty clear, right? So that means that's our 2.2. Which makes a lot of sense, I guess so. This part over here. No, don't mind this one. Like I said, you just need to avoid that part, because it was just for you to just cram. If it doesn't get in the mind, just cram it. Just cram it. But I don't advise you to cram it. But if it does not, just cram it. Right? Okay. So, and then the 2.3 says right on the IUPAC name for compound C. What's a compound C? Let's go up a little bit. A little bit. What's a compound C? A compound C is this one at the top. You see, a compound C is this one. So it has, let's start to name this one. We can start on this side. We can start on this side. So which side can we start? We can start on this side because we see a side chain. First we see near. It's very near, but this one is very far. So 1, 2, 3, and 1, 2, 3, 4. You see? So you can start on this side because this one is near. And also at the same time, the side chain over here. The side chain over here, it's near. You're going to say 1, and then you go right. Like, don't just go like this. If you go like this, that's going to be wrong. Don't say this is our side chain and you neglect this one. And be like, okay, this is how we move. We don't just move straight always. We can just move up, down, sideways, and stuff like this. So, be aware of that thing. So we can start on this side. 1, 2, 3. Because you see this one is 1, 2, 3, 4. We cannot start on this side, right? So we're going to start with this side. So we're going to say, let me write it over here. We're going to say, maybe let me just write it over here so that you don't get confused. All right. So we're going to say, Let me just a little bit, guys. It's 3 because we find this one on the 3rd carbon, and then another one on 5 carbon. Dichloro, hyphen 4 hyphen methyl. Methyl what? Let's see. This one is methyl. Then 1 2 3 4 5 6 7 8. It's what? Methyl what? Hexane. Methyl hexane. Alright, methyl hexane. Guys, my handwriting is bad. Right, so but then let's just not focus on my handwriting. Focus on what I'm saying. Methyl hexane. Alright, so because why did I put the 4 over here? Is because we found this side chain which is a methyl on 1 2 3 4, carbon number 4. I put the 4 over here. C, I put 1 2 3. I got it on number 3 4 5, number 5, and because there are 2, I said dichloro. 1 2, right? Guys, can you see this thing? I'm not sure if you guys can see this thing. I said 1, guys. I've noticed that you guys cannot see me. I said 1 2 3, this one. 4 5, this one. Because there are 2, I put di, right? And then I go up again and I say 1 2 3 4. It's methyl. The side chain is methyl. It's on carbon number what? 4. And then it's okay. Then I put the 4 and I put hyphen methyl, and then I go okay. Now I'm fine with the side chains and the side groups. So what's left for me is just to identify the compound, like just the general like. So we're just gonna say 1 2 3 4 5 6 7 8, and 8 is what? Hexane. And I put the hexane, and that's how we can name our thing. That's 3 marks, remember. Okay, so compound D. Let's see compound D. This one. What's a compound D? What's a compound D, guys? You can pause the video and try to do this. This is you can practice like while we're doing this thing, just to see if you understand what I've said. Okay, so we have this part. Okay, we have 1 2 3. This one, if you see this thing, but it's in 2 carbons, you know that this is a what? It's a ketone. So yeah, so our answer would be what? A ketone. Let's put a ketone over here. Ketone, because of what? A carbon bonded to O and is bonded to 2 carbon atoms. Alright, so that's how we can actually identify that. So, alright, so write down the IUPAC name of the functional isomer of D. Functional isomer of D. Okay, let's go up and try to see what's a D. What's a D? D is this one. So let's say, what's the IUPAC name? IUPAC name. So guys, I'm not sure if you guys have seen this. So here we had to put a propane because they said IUPAC name, guys. I'm sorry for this thing, but you have to put the propane because they say IUPAC name. We are not done here. It's a propane. You're gonna have to bear with me, guys. This one we're just gonna cut it out. This one we're just gonna cut it out. Okay, so that's the propane. Okay, so let's go for 2.4. It says the IUPAC name of the functional isomer of D. Functional isomer of a D. Okay, what's the functional isomer of adenine? Like I said, this one is what? It's a ketone. So what's the functional isomer for ketone? Is a what? Aldehyde. Hope you remember that. Hope you remember that. Of a ketone, it's aldehyde. Then we just gonna simply say change the functional isomer. I mean, you're gonna change the functional group and say this is proper now, because now it is a what? It is a what? An isomer. Now it's no longer there. That one is also is now an aldehyde. Now that's why we put the anar. Okay, so hope that makes a lot of sense. All right, so let's go for the last one. For the last one is this one at the top. You see this one at the top. So they say to you, write down the structural formula. Okay, structural formula of chain isomer compound A. Of chain isomer compound A. Okay, so let's try to see what's a compound A. It's a structural formula of a chain isomer of compound A. Compound A is a butane. So what's the structural, or maybe what's the structural formula of a chain isomer of compound A? Remember that chain isomer are the compounds that have the same molecular formula but with different different chains. Alright, so what's that? So let's try to draw this one. You can represent it in this way, and then you put the C, and then the top you put the C again, because that's a butane, has to have 4 carbons. And then you're gonna put the H over here, put the H at the top again, at the top, on the side, and also this one, how many? 1, 2, 3. 1, 2, 3, which means this one also has to have an H, because it has to have what? 4 bonds. So this one's you're gonna put the H also, and this one you're gonna put the H, and this one you're also gonna put the what? The H. This one is the H, guys. It's better than this one. So that's how we can actually write that. You see? So that's for compound E. I mean compound A. So they go again and say write down the compound E. Alright, so the structural formula of a compound E. Okay, so how can we write the structural formula of a compound E? And what actually is a compound E? Compound E is a butanoic acid. Then you just need to write the structural formula for butanoic acid. So it has 1, 2, 3, 4, because it's a what? It's a butane. And then I'm gonna write the bonds over here, and then the bonds, and then the bonds over here. You put the H, 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 and put the H. And then this one, because it's a butanoic acid, you're gonna say, okay, put this one and this one. And that's how you can actually write the structural formula for the what? For the butanoic acid. Alright guys, I hope you guys enjoy the video. So don't forget to like, share, comment, and subscribe, and I will see you in the next video, and tell other people about this channel so that we grow as a family. And yeah, take care of yourself. Peace.